Hello grade 11s. Today I am back. We are going to do atomic combination and intermolecular forces. So before that, we will start looking at our periodic table. Now, when you have your periodic table like this, you have to name this group 1, group 2, and then we will move. Don't mind this orange part which is in the beginning, in the middle, sorry. We'll have group 3, group 4, group 5, group 6, group 7, and group 8, just like I have done. So with Lewis diagrams, we look for valency electrons, right? So let's say, for instance, we are looking for let's do carbon. Carbon is this side, it's in group 4. So in order for us to get to carbon, we'll start here. This is 1 and this is 2. Those are valencies. Those are electrons, sorry, the inner electrons. So if we have an atom, let's draw this like this. This is an atom, it's a carbon. This is the outer side, this is the inner side, right? So we have protons and neutrons inside the nucleus, right? So when we are looking for carbon as the atom, we're gonna start here. We're gonna count from hydrogen. Hydrogen is 1, and then we're going this side. In the first row we have helium, right? That's number 2. So our inner valencies are gonna be 2, right? Those not valencies, electrons. These are electrons. So we need to find electrons on the outer shell as well. We'll see lithium 1, beryllium 2, and then just going with that, we have 3, and this is 4. So those ones are outer. They are called valency electrons. They are 4. So this is a valency electrons. When you are trying to draw a Lewis diagram, that is what you have to look for. Valency electrons. So here we are going to do just that. Now let's look at boron. Boron is here. The valency electrons, we have 1, we have 2, and this is 3. We're not going to look at the first ones because we are not dealing with that. Here, with a Lewis diagram, you only look for the valency electrons. This ones at the first row, it's electrons, but we need the valencies, the ones outside. So it's 3, it's in group 3, which means it needs to have 3 valency electrons like that. So you can start here, go in the side, or start here, go in that side. Do whatever your teacher has told you to do. Now, the other thing we can look for is chlorine, right? Chlorine is here. It's in the 3rd row. If we were writing it as an atom, here we will have 3 rows because what is in the 3rd row, chlorine. But we will calculate, we count from here, 1, 2, 3, 4, 5, 6, and 7. Chlorine is in group 7. So when chlorine is in group 7, we will have here, we'll start here, 1, 2, 3, 4, we still can add more, 5, and 6. You see, those are the valency electrons of chlorine. It's a Lewis diagram of chlorine. Now we can look for neon. Neon is here in group 8. when you calculate from here is 1 2 3 4 5 6 7 8. It's neon. I forgot the E here. That's neon. So neon is fully surrounded. 1 2 3 4 5 6 7 and 8. So it is fully surrounded. Neon is very happy. Now the next thing we are gonna do now is bonding electrons. All right, now we are going to bond electrons, right? So let's bond oxygen and hydrogen. Now let's come back to your periodic table. Let's look for oxygen. Is in group 6, so it will have 6 valency electrons. 1 2, it will have the first one 1 2 3 and 4, and we still have 2 to distribute, so that will be 5 and 6. You see, we have 6 valency electrons with oxygen. Now we are bonding it with hydrogen. Hydrogen is in group 1, which means it has 1 valency electron. So we in order to bond this together, this will go with this one, right? So it's not fully surrounded, which means we need to create another hydrogen for this oxygen to be fully surrounded. So what we do, we generate one more hydrogen to complete the structure, and it will be water. So we will have 2 hydrogens and 1 oxygen, so that will be water. Now this is the new structure. This is the hydrogen that we had. It has bonded with this part, the oxygen, and another one that we've just created is bonding with this one. This oxygen is fully surrounded, and we have what we call H2O. So 2 hydrogens and 1 oxygen. We have created a bond. And this, when we are doing this valency electrons, this part and this part are full. They have 2 2. That's what you want to have when you are bonding. You want this oxygen to have 2 here and 2 this side. So that is a loner pair, meaning they are happy because they are full. So this side and this side, they are loner pairs. So this will be called electron pairs. They are loner pairs and they are all happy. Yeah. So this is a lone pair, and this one is a bond pair because they are between 2 electrons. You see? So this will be lone pair and this one will be bond pairs. So for the next example, let's try to bond nitrogen and hydrogen. So hydrogen is in group 1, so it has 1 valency electron, and nitrogen is in group 5, so it has 5 valency electrons, which will be 1 2 3 4 and 5. Now we have to bond these 2. We only have this one that will probably connect to this one, but these 2 ones have nothing. So we will generate 3 more hydrogens, and we'll have the structure like this. X. You can do it by circles. Just do it the way your teacher has taught you in class. So we are going to generate a hydrogen there, a hydrogen there, and hydrogen there. So this will be our new structure. It's fully, now we have bonding pairs and lone pairs here. So this is called, this will be NH2 H3, 1 nitrogen, 3, 1 nitrogen, and 3 hydrogens. So N3, and that is ammonia. They can also ask this. They can also give you this bond in an exam. I've seen it where it's given in